Ajitesh, everybody, good afternoon. Okay, so now look at that. So in our previous class, we have discussed about that modulus of a complex number and representation of a complex number in my organ plane. Okay, we have discussed some modulus properties also. Right, some student asked some doubts in previous class. So explain about that second result, third result, like that. So your modulus of Z1 by modulus of Z2. This is division of two complex number. It is a complex number, and take the modulus of that division the complex number, new complex number. After dividing this Z1 by Z2, you will get new complex number. The modulus of this new complex number is equal to, okay, modulus of Z1 divided by modulus of Z2. Both are equal. This result already I gave yesterday. Why? Because yesterday I gave some results. What is the problem in that? Okay, so now look at the results. So these results we have already discussed in our previous class. For any two complex numbers, for any two complex number Z1 and Z2. Okay, so the first result is modulus of Z1 plus Z2 equal to modulus of Z1 plus modulus of Z2. Okay, suppose I am taking my Z1 is equal to some 1 plus I. My Z1 is the complex number 1 plus I. My Z2 is the complex number 2 plus I. Okay, when you add these two, what is the answer we are getting? My Z1 plus Z2 is equal to 1 plus 2. How to add that? Real numbers, real part and real part, you have to add it. That is the addition of two complex number we have already discussed. So this is 3 plus. Now look at that. This is your I is common. Take it outside. Here also 1. Here also 1. That is 2y. My Z1 plus Z2 is the 3 plus 2y. Then find the magnitude. Magnitude means modulus. My modulus is nothing but a real part square plus imaginary part square. Okay, so therefore the answer is 9 plus 4. That is root 13. Okay, so my left hand side is root 13. Come to the right hand side. My magnitude of Z1. What is the magnitude of Z1? Okay, magnitude of Z1 is nothing but this is so this is magnitude of Z1 is root 2. That is root of 1 square plus 1 square. Okay, so therefore this is magnitude of Z2. What is my magnitude of Z2? So this is nothing but 2. Okay, my magnitude of Z2 is, this is, okay, so this is 2 square 4 plus 1. Okay, so therefore this is root 5. Okay, so therefore this is 3 plus 2y. Am I correct? This 1 plus I, 1 plus 2y. Okay, so therefore this is, and what is our modulus of Z1 plus modulus of Z2? So this is root 2 plus root 5. Okay, what about your root of 13 value? The value of root 13, how to find out? So you have to go for that long division method. Okay, or otherwise you have to use some calculators or other things. Okay, so therefore what is my root 13 value? Any value for root 13? It may be nearly 3.6. Okay, Right. What about this root 2 plus root 5? My root 2 is 1.414. Okay, right. My root 5 is my root 5 is 2.23. This is maybe 2.23. Okay, if you add these two, you will get 3.6. Okay, so approximately both are equal. So I'm getting here also I'm taking approximately, here also I'm taking approximately. So these two are equal. Okay, so therefore modulus of z1 plus z2 is equal to modulus of z1 plus modulus of z2. Okay, for any two complex numbers. If you take any two complex numbers, this is true. This z1 plus z2 more or less magnitude is equal to magnitude of z1 plus magnitude of z2, both are equal. Okay, please try to understand this. This is the first result. Come to the second result. What is my second result? My second result is modulus of z1 by z2 is equal to modulus of z1 by modulus of z2. This is my second result. Take the same example. Take the same example 1 plus I. My z2 is equal to 2 plus I. What is my z1 by z2? Division of two complex number. My division of two complex number is nothing but 1 by z1 into 1 by z2. What is the 1 by z2? It is the multiplicative inverse of z2. How to find out the multiplicative inverse of z2? So this is my 1 plus I. Okay, what is the formula for finding the multiplicative inverse of z2? Multiplicative inverse of z. If my z is a plus ib. Okay, so is equal to, so this is z bar. How to find out the multiplicative inverse? That is z bar divided by modulus of z square. We have another formula also, a divided by a square plus b square plus I into minus b divided by a square plus b square. That is also correct. Okay, either this formula or this is the multiplicative inverse, a divided by a square plus b square plus I into minus b divided by a square plus b square. Both are correct. Apply that. So therefore, my multiplicative inverse of z2 is nothing but this is my a, this is my b. Please try to understand, because I am going to finding the multiplicative inverse of z2 only. This is my a, this is my b. So a divided by a square plus b square plus I into b divided by minus b. So minus 1 divided by this 2 square plus 1 square. Okay, so therefore this is 1 plus I into, so this is 2 divided by this 2 square 4 plus 1, it is 5. Okay, and this is minus I divided by this is 4 plus 1, it is 5. Now multiply. What is the answer? Multiply this 1 into 2 by 5, this 1 into minus I by 5. So that is 2 by 5 minus I by 5. Okay, and multiply this I. So therefore plus 2 by 5 of I. And multiply this I into this. Okay, so therefore this is minus I square by 5. What is my I square value? My I square is minus 1. I is root of minus 1. I square is minus 1. So therefore this is 2 by 5. This I square is minus 1. Please note that this I square is minus 1. Minus of minus becomes plus. So therefore 1 by 5. These two terms are called as real parts. Why? There is no I. No I means that are called as real parts. Okay, but look at that, in these two terms some I is there. Here minus 1 by 5 I. Here plus 2 by 5 I. Subtract 2 by 5 I minus 1 by 5 I is nothing but 1 by 5 I. So therefore this is 3 by 5 plus I by 5, 1 by 5 of I. So this is nothing but my z1 by z2, division of two complex number. division of two complex number is nothing but, okay, so finding the multiplicative inverse of Z2 and multiply with Z1. Okay, so that is a division of two complex numbers. So now take a modulus, modulus of Z1 by Z2. What is my Z1 divided by Z2 modulus? This is the Z1 by Z2. Your division is also another complex number. Your addition is also another complex number. Your subtraction is also another complex number. Where Kanna? Arshini. Arshini, this is, yeah, Arshini, see this. I'm going to taking, this is my complex number. I'm going to find out the multiplicative inverse of this Z2 only. So 2 plus I means here 1 is there. So this is my A, this is my B. A plus IB. Compare these two. What is your B? Are you okay? Arshini, are you okay? BS1. Why I am taking BS1? Okay, very good. Well, what is root 34? This answer is root 34. Huh? Which one? Where I have to apply the first formula? Yeah, this formula. Yeah, that is your choice only. Your choice only. Okay. Right. So now come to that. There are two many formula to find out the multiplicative inverse. One is this, one is this. Whichever is easy for you, you proceed. You will get same answer. This is 3 by 5 the whole square magnitude modulus 3 by 5 the whole square plus 1 by 5 the whole square. Okay, so therefore this is nothing but this is 3 by 5 the whole square means 9 by 25. Here 1 by 25. Okay, so totally this is 3 by 5 the whole square, 9 by 25, here 1 by 25, totally 10 by 25. Okay, you please take it as, look at that, this is 10 by 25, you cancel by 5. So therefore this root of 2 by 5. Is it okay? My final answer is, this answer is root of 2 by 5. Not 34, Monisha or somebody is giving the answer. 34. What is 34? Yeah. Okay. So now this is I am getting the left hand side answer. Modulus of magnitude of Z1 by Z2 is root of 2 by 5. Come to the right hand side. What is my right hand side? My magnitude of Z1 is nothing but root of 1 square plus 1 square, that is root 2. What is my magnitude of Z2? My Z2 is nothing but 2 square plus 1. So that is 4 plus 1, 5. So what is my Z1 by Z2? Magnitude of Z1 by magnitude of Z2 is nothing but root 2 by root 5. So this is nothing but root of 2 by 5. Look at that, both are same. Magnitude of Z1 by Z2 is also root of 2 by 5. Magnitude of Z1 divided by magnitude of Z2 is also root of 2 by 5. So therefore, my Z1 by Z2. That means here, after dividing these two complex number, I am taking magnitude. Here, I am taking magnitude for the first complex number and second complex number and then divide. Both the answers are same. This is my property result. Are you okay? I understand. Which one? Dikshita, what is your doubt? I can't understand. And Yalini, not Yalini, Judith Jarvi. What is your doubt? Dikshita, what is your doubt? Yeah, we have class tomorrow. Where I am taking Z2 modulus Z modulus Z2 Z. Are you okay? Right. Shall we move to the next? I square minus 1. Okay. Anna Rahul. Rahul, please try to understand your A is Z equal to A plus IB. Okay, your magnitude is root of A square plus B square alone. Don't consider this I. Okay, this is my real part, this is my imaginary part. You just uh, take a square of real part, take a square of imaginary part and add these two and take a root. This is my magnitude. Don't consider your I. This is my magnitude. See the definition of the magnitude in our previous class. We have discussed that. This is the definition of magnitude. Don't consider I. Are you okay? Are you clear? How we are getting this formula also I have explained in our previous class. No, if there is Rohit, if there is no modulus in both the sides, it is also same. Same only. My this is both are same. It is an obvious one. It is an obvious one. Okay, I will tell you, Rangapriya. I will tell you. Okay, right. So now come to that another other results, and these results we have already discussed in our previous class. I'm just repeating the others again. Z1 into Z2 equal to Z1 bar into Z2 bar. So I'm just writing the results. You please go through the results and prove the results by some examples. Okay, that's equal to Z1 bar some minus Z2 bar. That means here look at that. You add these any two complex number and take a conjugate. That is equal to take a conjugate separately and then add. Both are same. Okay. So and the fifth one and Z1 by Z2, the whole conjugate. After dividing two complex number, take a conjugate. That is equal to taking conjugate separately and then divide. That is also same. So therefore here that Z2 is not equal to 0. Okay, right. So these things we have discussed in our previous class. We'll discuss some more problems and then we'll go to that organ plane. Conjugate also we have explained in our previous class. Okay, so how to find out the multiplicative inverse? Find the multiplicative inverse of the first one. Suppose 2 minus 3i. How to find out the multiplicative inverse? Suppose that's equal to 2 minus 3i. What is the formula for multiplicative inverse? Multiplicative inverse multiplicative inverse of Z is equal to Z bar divided by modulus of Z square. This is another formula. Okay. Then what is my multiplicative inverse of this? My conjugate is 2 plus 3i. Look at that. If Z is equal to a plus ib, then conjugate of Z is denoted by Z bar. This is nothing but a minus ib. Okay. You change this b as minus b. Okay. Whatever given here b, you take it as minus b. That is the conjugate of the given complex number a plus ib. Okay. So therefore here 2 minus 3i is there. My b is minus 3 here and take it into plus 3. So therefore this is my conjugate. Okay. And now take that modulus. What is a modulus actually? Root over 2 square plus 3 square. Actually root over 2 square minus 3 the whole square. Why? Here modulus of Z the whole square. This is my modulus of Z the whole square. So therefore my answer is 2 plus 3i divided by, this is the square root and square will be cancelled. I will get 2 square is 4 minus 3 the whole square is plus 9. So therefore I will get 13 only. So therefore this is 2 by 13 plus 3 by 13 of I. This is my multiplicative inverse. Okay, suppose come to the second problem, how to find out the multiplicative inverse of this root 5 plus 3i. Okay, suppose you take z equal to root 5 plus 3i. What is my multiplicative inverse? Look at that, my symbol is z inverse. Z inverse is the my multiplicative inverse symbol. Okay, my z inverse is, okay, z bar divided by modulus of z the whole square. What is my z bar? Conjugate of this. What is a conjugate? A plus ib is a complex number, then a minus ib is my conjugate. Root 5 plus 3i is the my complex number, then root 5 minus 3i is my conjugate. Divided by, take a modulus. Modulus square. Root of root 5 square, okay, plus 3 square the whole square, because look at that, modulus of z the whole square is there. So therefore this will becomes root 5 minus 3i divided by root 5 the whole square is 5 alone. Okay, but my 3 square is 9. This square root and square will be cancelled. So therefore 9 plus 4 it is 9 plus 5 it is 14. So therefore, my multiplicative inverse is root 5 divided by 14 minus 3 divided by 14 of I. Okay, so therefore, this is my multiplicative inverse. Okay, so look at the next problem. What about the value of express in A plus IB form? Some problems in express in A plus IB form. I power 9 plus I power 19. How to express this is in A plus IB form? How to apply this is in, we can test first chapter fully. Okay, I power 9, I power 19. I have already told that I power 4k. So this is 1. Multiples of 4. Your power is multiple of 4. That is 1. I power 4k plus 1. Okay, so that is my I. So therefore I power 4k plus 2. Okay, so this is nothing but minus 1. So my I power 4k power is 4 multiples of 4 plus 3. So then this is minus I. Okay, now look at that. My I power 9 is, okay, I power 8 plus 1. Multiples of 4 plus 1. Multiples of 4 plus 1 mean that is I. Similarly, this is I power 19. What is my I power 19? Multiples of 4. 16 plus 3. Multiples of 4. So therefore, my I power 8 is multiples of 4 plus 1. Multiples of 4 plus 1 means this is my I. This is multiples of 4 plus 3. Multiples of 4 plus 3. This is my minus I. So therefore, the answer is 0. So, but the question is A plus IB forms are, yes. This is my 0 plus I0. That 0 is also my complex number. Okay. Sometimes they are asking I power 39, minus 39. What is I power minus 39? This is nothing but 1 by I power plus 39. Okay. What is I power 39 can be written as I power 36 plus 9. Multiples of 4. This 36 is nothing but multiples of 4 because I'm going to apply this formula. Multiples of 4 plus 1, multiples of 4 plus 2, multiples of 4 plus 3. Here multiples of 4 plus 3. So therefore this is my answer. So therefore this is 1 by minus I. But this is not a plus IB form because your I is in the denominator. Okay, then what to do, sir? You just multiply numerator and denominator by I. So therefore here it is 1 into I. Here it is minus I square. What is I square actually? My I square is minus 1. Okay, so therefore minus 1. This is minus 1. I divided by minus 1. This is nothing but minus I. This is nothing but 0 minus I. A plus IB form. Are you okay? Are you clear? Any doubt? Okay. Any doubt? Yes, I square is minus 1. Which one? Somebody is Monishwar, not Monishwar. Yeah, yeah. So here my I square is minus 1. Already one minus is there. Plus 1 only. I'm sorry. Here already one minus 1 is there. I square is minus 1. Minus 1 into minus. That is plus 1. So therefore 0 plus I. The answer is 0 plus I. I power minus 13 is 0 plus I. Yeah, right. Thank you. Now come to the next problem. How to apply for that? Express in A plus IB form 1 plus I the whole power 4. Okay. So do you know the A plus B the whole power 4 formula? I'm going to apply the same formula. A plus B the whole power 4. What is A plus B the whole power 4 formula? A power 4 plus 4 A cube B plus 6 A square B square plus 4 A B cube plus B power 4. Do you know this formula? I'm going to apply the same formula. Okay, my A is 1, my B is I. A is 1, 1 power 4, okay, plus 4 into 1 cube into I. 1 cube is 1 only, plus 6 into 1 square into I square. 1 square is nothing but 1, I square, plus 4 into my A is 1, 1 into I cube, plus my B is I power 4. So therefore, this is 1 plus 4I, okay, plus 6 into my I square is minus 1, okay, plus my 4 into this, my I cube is minus I, my I power 4 is plus 1. How you are writing I power 4 is plus 1, sir? Look at the power. If the power is the multiples of 4, my I power 4k is 1 only. I'm using this formula. This is we have already discussed. Okay, I'm using this. And now look at that. Here, there is no I. This term there is no I, and this term also there is no I. Therefore, these two terms are called it as my real parts. That is 1 minus 6. This is called as real part. And these two are called as here minus 6 plus 1 is also there. Yeah, you have to add this plus 1. These, because there is no I in these three terms. Okay. So therefore plus I into, so here 4I, here minus 4I. You take I is commonly. So therefore the answer is, this is minus 4 plus this is 0I. Here it is 0. So therefore this is a complex form. Minus 4 plus 0I. Okay. Very clear? Any doubts? Yeah, you have to know the formula. A plus B the whole power 4. It is a easy only. So, Pavan, A plus B square into A plus B the whole square. Yeah, you multiply that, you will get the A plus B the whole power 4. Derive the formula. But it will take some time. But don't do all these things in your exams. A plus B the whole square into A plus B the whole square, because A plus B the whole square having 3 terms, A plus B the whole square another 3 terms. You have to multiply, you will get 9 terms. After multiplying, after getting 9 terms, you got to simplify, you will get 5 terms. That will take much more time. Okay, better you understand the formula. Some logic is there to remember all these formula. A plus B the whole power 4, A plus B the whole power 5, A minus B the whole power 5, A minus B the whole power 6, everything from square to bigger formula. You please understand that logic. Okay, some Pascal triangle is there. Using Pascal triangle, we can easily understand, we can easily remember all these kind of formula. You please try to understand that triangle and understand that logic. Okay, right. Now come to that. The next one, organ planes. This is also we have discussed in our previous class, and I am going to again teaching organ plane. Okay, the plane having, take the definition first. The plane having a complex number, the plane having a complex number assigned, complex number assigned to each of its points. Assigned to each of its points. Okay. Each of its point is called complex plane. It's called complex plane or the organ plane. What is plane? This is consisting of the set of all ordered pairs. Okay, so this is okay. If I am representing some complex number, that means every point is representing in this plane is a complex number, then that plane is called as complex plane or organ plane. Okay, in this organ plane, in the organ plane, the modulus of the complex number x plus iy, the modulus of a complex number x plus iy is, modulus is defined as root over x square plus y square. How we are getting this formula? Suppose this is my x comma y. Okay, so that means this distance is my x, this distance is my y. Actually, this is my modulus of x, modulus of z. So this is nothing but by Pythagoras theorem. What is my Pythagoras theorem? Okay, this side, the square of this side is equal to sum of the squares of these two sides. That is a Pythagoras theorem. Okay, so therefore this length is equal to modulus is equal to or magnitude is equal to, that is defined as root of x square plus y square based on this. Okay, so therefore the modulus of a complex number x plus iy is nothing but root of x square plus y square. What is this? This is my modulus. What is this? This modulus is root of x square plus y square is the distance between the point, is the distance between the point. Okay, you can take it as this is P, the point P and the origin. Point P and the origin. Okay. You please take that. What is the modulus? Modulus is the distance between the point and the origin. Yeah, the same thing. Complement and difference totally cancel in the first chapter. Yes. Are you okay? Yeah. If you completed means we will go to the next. So look at that. The points on x-axis, the points on my x-axis corresponds to the complex number, corresponds to the complex number of the form a plus I0. So if you take a point on, look at that in this diagram, if you take a point on x-axis, okay, that complex number is represented as a comma 0. This is a comma 0 or x comma 0. Okay, so therefore this is represented as a plus I0. The point is a comma 0, but the complex number is representing as a plus I0. Similarly, and my y-axis, okay, corresponds the complex number of the form, okay, 0 plus IB. My y-axis corresponds the complex number of the form 0 plus IB. Okay. So if you take, look at that, if you take any point on the x-axis that represents a comma 0, my complex number representing the points on the x-axis is a plus I0. Suppose I am taking a point here, this is nothing but 0 comma some b. So my complex number representing the points on this y-axis 0 plus IB. This is imaginary axis. This is real axis. Whenever you are taking the y coordinate, you have to put some I. A plus IB. That is a complex number, representation of complex number, right? So the axis, the x-axis and y-axis in the organ plane, the x-axis and y-axis in the organ plane okay, are called real axis and imaginary axis, real axis and imaginary axis respectively. Okay. Yeah, some students asking, sir, what is conjugate? See that one of the students asked that conjugate, sir. What is conjugate, sir? See this diagram. Suppose I am taking P here. This is some x comma y. X comma y means my complex number is x plus iy. The complex number is x plus iy, but if you are representing the complex number means it is representing as x comma y, point x comma y. Okay, so therefore this point is nothing but q x comma minus y. Look at that, here the x coordinate is same, but y coordinate is negative. Okay, so this point is called as my conjugate, right? This is my origin. So now the conjugate of P is my Q. So here the conjugate is x minus iy. X is same, x coordinate is same, only y coordinate here plus y, here minus y. This is nothing but the minor image. Z is the Z bar is the image of the complex number Z. Q is the image of P. That image is called as conjugate. That is called as a minor image. So why, sir, we are calling as minor image? Okay. So if you take here also, this is minus P. That is the image. If you take this is P, then this is the image. Okay. If you take like this mean, that is a minor image. Or we can call it as image also. So therefore, this is a minor image. Q is the minor image of P. That minor image is called as your conjugate of the complex number. Okay. So therefore, let z is equal to x plus iy. Okay, then its conjugate, z bar equal to x minus iy. Okay, P and Q are representing z and z bar in organ plane. Are you understanding? Any doubt? whatever we have discussed in our previous class, I am telling everything. Okay, I am giving some notes for that. Okay, my P and Q are representing Z and Z bar. That means P is the given complex number and Q is that image. That technical name we are using, that conjugate. Okay, slide 12. This is our first slide, I think. Why you want slide 12? This is our first slide, slide number 24. Someone is asking that slide number 12. Slide number 12 means you are asking that previous day. Threes. The threes. Why you are asking slide number 12? Chandru, what is your doubt? 28. Yes, this is. Chandru, what is your doubt? Yeah, we have a class tomorrow. Why? What is the problem? What tomorrow? What about tomorrow? Yes, you please take that. I will show the slides. Please take it fast. We completed. Shall we go to the next slide? Any doubt in this? If you have any doubt, please ask your doubts. Otherwise, we'll move to the next. Slide number. No doubt. Oh, okay. Okay, pa, we'll intimate later. I don't know. We will intimate later. Don't worry. Yeah. Yeah, finally I will show all the slides. Don't worry. For some minutes, I will showing all the slides. Okay. Right. Now look at that and take this note also geometrically. The point x comma minus y is the minor image of the point. Minor image of the point. X comma y on the real axis. Okay, the point, this is actually point Q. This is actually point P. Q is the minor image of the point P. Okay, any other doubt? X should be, no, X should be in positive only. So we are taking that my image in X axis. Okay, minor image. Yes. Okay. Yes. So now please come to that. So this is my organ plane, y-axis, my x-axis. Okay, right. You please, somebody tell some complex numbers. We will plot the complex numbers in organ plane. Please tell some complex numbers. We will plot the complex numbers in our organ plane. Yeah, this is not a mirror image, not a minor image, mirror image. Yeah, correct. Mirror image. This is a mirror image. Yeah, okay, look at that. Yeah, this is called it as a mirror image. Okay, not a minor image, mirror image. Right. Now you please tell me some complex numbers. 2 plus 3i, 3 plus 0i. Yeah, look at that. 3 plus 0i means the point 3 comma 0. That is my complex number. That is the point. If you take z is equal to 3 plus I 0i, then my point is 3 comma 0. That is this is my 3 comma 0, right? Some other point. 9 plus 3i minus 3 plus I. Somebody is telling minus 3 plus 5i. Okay, minus 3 plus 5i means, so here the point is, what is my point? Minus 3 comma 5. So here minus 3, here it may be 5. So therefore this is minus 3 comma 5. This is my complex number. Any other? Minus 4 plus 2i. So this is minus 3. So you can take it as minus 4 here. Minus 4, you can take it as this is plus 2. So therefore this is my minus 4 comma plus 2. This is a complex number. That means your complex number can be converted into the point. 5 minus 6i. This is taken as 5, some 5. And this is taken as minus 6. Okay, 5 minus 6i. This is my 5 minus 6i. Okay. 0 minus 3i. Somebody is telling 0 minus 3i. 0 minus 3. That means this is my 0 minus 3. This is my complex number. Are you okay? Any doubt? Any other doubt? Any doubt, Kana? Yes, yes. Mirror image only. The conjugate is the mirror image, or simply called as image. No problem. Simply called as image or mirror image. Okay, right. So I hope that you can easily understand that representing complex number in organ plane. Are you okay? Any other doubt? O plus. Any other doubt, Kana? Yeah, both are same. Yes. Mirror image or image, minor image, all are same only. You can simply call as it is image. Right. So I will show the slides. What is the image? Yeah, this is my first slide. Okay, so dear students, suppose if you take a mirror here, okay, suppose if you take a point here, then this is a mirror. Yeah, consider this is your mirror. Okay, so if you take a point here and the image in your mirror is here only, you can see the image in your mirror is like this. Therefore, if this line is act as a mirror and this is the original point, then the image of this original point is coming here. if this is acting as a mirror. So therefore this point is called as your mirror image of this point. Okay, here in our complex number, my x-axis is the mirror. I am taking a point P here, and the image of this P is, according to this mirror x-axis, this is my image Q. This image is called it as my mirror image of this point P. Are you okay? Are you okay, Kana? Yeah, image only. Yeah, you can call this image, or simply minor image or mirror image. All are simply called as image. No problem. Okay, these are our slides. So please try to complete the homework problem. Yesterday also I gave some homework problem. Today also I gave some homework problem. You please try to complete all the homework problems. Okay. Yes, geometrically it is a image. Yeah, you maybe get it today. Those who are not getting homework yesterday, you maybe get it today. Which slide you want? Arti. Arti, if you want any slides, which slide you want, Arti? Third and fourth slide of today. Okay, so now look at that. I'm starting from the beginning. This is our first slide. Okay, you said okay, then only I will move to the next. Okay. Thank you. Thank you, all of you others. Thank you. Thank you so much, everyone. Yeah, that's all, Arti. Yes, thank you. Thank you, everyone. These are our other slides. If you want, take a snapshot. Okay. Thank you, everyone. Thank you so much. We'll meet tomorrow or in next class.